here. You may have tried it out. For those who tried it out, I had not specified that this is a normal, and therefore there could be some information that you misinterpreted, or you probably interpreted right. Because if the normal is not specified, then one can choose that this becomes the normal. Actually, I need to mention about this. Sometimes the question is set, if we assume the normal is right over here, that would imply that the angle they gave you here for the incident ray, because you look at the arrow to identify the incident ray, would now not be an angle of incidence. It would be a glancing angle on this face. But if they specify that the normal is here, like we are going to take the case, it implies that 30 degrees becomes our I, and 24 degrees becomes our R. The question required us, in a summarized way, to find the refractive index of glass, to find the absolute refractive index of glass. That's why I've written it like that. So we shall use I want to remind you that we derived our expression of n sine I is a constant, where my k represents a constant. If we use n sine I as a constant, we look at the media where the incident ray is coming from, and that will be that n glass, because the whole of this is glass. N glass, the sine of I as 30 degrees will be equivalent to n water, the medium where the refracted ray is, the sine of R. We are saying n sine I is a constant, but I is treated as an angle of incidence if we assume that that ray is retraced to come back along the same path. So our I is 30 degrees, our R is 24 degrees, and we are looking for the absolute refractive index of glass. The refractive index of water is known. So if we say our n, the sine of 30 degrees would be equal to 4 out of 3, the sine of 24 degrees. And our n glass, if made the subject, would be 4 over 3, the sine of 30 degrees over the sine of 24 degrees. This is where I will tell my learners to get out their calculators and compute. When you compute using a calculator, you will be able to get that absolute refractive index of glass is what we want. So when you compute using your calculator, you will be able to get that our sine of our Ng will be equal to 4 times the sine of 24 divided by 3 times the sine of 30. When you compute, it will give you a figure that we can look at as 1. It is 1.08. We can record it to 3 dPs as our n glass. I is 30 degrees, R is 24 degrees. Our n glass becomes that. It becomes this. Another student who chooses to do it the other way around would begin with the 4 over 3, the sine of 24, should be equal to n glass, the sine of 30. We are not using A because if it is absolute, it is assumed that it should be air. So when you compute it this way, you should be able to get our answer as that. $1.085. The second question was telling us to calculate the angle of incidence if the angle of refraction is 30 degrees. So for this part, if I may sketch, they are telling us determine the value of I if the angle of refraction is 30. So our sketch would be that, where this is 30 degrees. And if they are telling us to determine the angle of incidence for an angle of refraction of 30, we will maintain the media as glass water, because the incident ray in the first diagram is coming from glass and the refracted ray is coming from air. Now, if we take the values now they gave us in the question, they had not given us the refractive index of glass. So you will ignore the 3 out of 2. That means we have to use this. Our refractive index of glass is our 1.085. And our I is what we want. Our R is 30 degrees. So using n sin I, is a constant, we shall again get the n that we have just got. The sine of I, which we are looking for, should be equal to the n water. N water is known. So 4 out of 3 times the sine of 30. For those following, they have told us that if the angle of refraction was 30, what would be the value of I? So we would be able to get our sine I as 4 out of 3 times a half times 1 out of 1.085. Why a half? The sine of 30 is a half. So we shall get our sine I as 2 out of 3 times 1.085. Remember that for the sine or the cosine, the maximum value should be 1 and the minimum value should be a negative 1. So our I, by calculation from there, will give us a value that we can get as, by computing that expression, we can get our value for sine I as 37.9 degrees. Note that in physics it is allowed to move from here to the answer and you get all the marks. The computations of first getting 0.6 something, and then you proceed to get the arc sine of I is equal to the arc sine of that value, then you state the angle. That detail will not deny you marks in physics. The next part, they are telling us to find the refractive index of water with respect to glass. Find the refractive index of water with respect to glass. We saw last time that Wn glass would be the same as Wn air times air n glass. And we also saw that if we have Wn air, it is the same as 1 over air nW for our water. Therefore, our Wng is the same as 1 over an water times an glass. We shall use the values that we have already. So we shall use our an glass, which is the absolute refractive index, to get our Awng as 1 over 4 over 3 times our 1.085. This is the same as 3 times that over 4. So it will give us a value that will be less than, it will give us a value that will be 3 times 1.085 divided by 4. We shall get the value of WNG as 0.81375. I would advise students that it is not good for them to round off such a figure. They would leave it at that stage. Lastly, they wanted us to get GNW, which we can fit here. Similarly, this is the same as GNA times ANW, and our GNW will therefore be, actually it is the same as the reciprocal of this. It is ANW over ANG. So it is going to give us the refractive index of water, which is 4 out of 3 times the 1.085 when we substitute. And when we compute, our GNW will give us a value of 1 point. This is 4 divided by 3 times 1.085. The students should be able to use their brackets very well on the calculator, and we can write this as 1.29. Let me write it to 2 dPs. We can write it as 1.29 as our answer. 1.29. That gives us the final bit of the values for that number that I left behind. For those that tried it out and assumed the normal was here, you should have got exactly those answers. For those that assumed the normal to be here, your answers should be correct if you took this as the angle of incidence. And therefore, the angle of refraction, if this was the normal, would definitely be that other angle, which is supposed to be 66 degrees. And therefore, the rest would be done that way. As you capture that number, I can put down our next question over here. I can put down our next question over here. And we work through it. This topic is seriously mechanical, that most of the numbers will require hands-on. So we have a question which you will have to copy after I have finished putting it down, but meanwhile, cross-check with your answers and capture them. Yes, our question is now ready. I will read through as I expect you to capture it. And as you are aware, the fastest means of capturing our questions here, in the interest of time, is taking a picture. Then you follow the working with the teacher, and you can refer to the question at leisure, even much later. The question says that a monochromatic light incident on a block of material placed in a vacuum is refracted through angle theta. If the block has refractive index n and is of thickness t, show that the light takes a time nt sec is short for second, sec of theta, to emerge from the block where c is the velocity of light. You may recall that at the start we looked at the relationship between refractive index and velocity of light. We will put our sketch right over here. We'll put our sketch right over here and proceed to work through it. If we take this as our block, they are telling us that monochromatic light is incident on a block of material placed in a vacuum. So that means this is air, which we are going to treat as our vacuum. And if we have light that is incident here, they are telling us that this light is refracted at an angle theta. So it is refracted here, and this angle is theta. We must remember to put an arrow. They have told us that the refractive index of the box is n. We can put it in here. And they have told us that that block has thickness t, which is ideally that. That is our thickness of the block. They are saying we should show that it takes a time nt sec of theta to emerge. Of course, this would be the angle of incidence, and this light would definitely emerge from here. But our interest is the time it takes inside the glass block should be the time taken along this length. If we call this point A and this point B, our interest right over here is to find out, I'm going to call this C, is to find distance AB. Since we know that speed, I'll put this here, that from speed is equal to distance over time, we are interested in finding the distance as speed times time. So we'll need distance AB, and we want to find the time it takes there. So the time from that expression will be obtained as distance over the speed. If we let the speed in this medium be, say, v1, we shall let the speed be v1 in the block. We have said this is our block, so we can get started. Let the velocity of light in the block be v1. Since we already know the expression that relates speed of light in one medium to speed of light in another medium, we shall use that expression. And I have already simplified that we are interested in distance AB and the time it takes to cover that distance AB. So we shall say from that expression that speed, allow me to summarize it, is distance over time. And we have said our speed is v prime. So the time, if it is t, will be the same as the distance, which I'm going to call AB. The distance is going to be AB according to our diagram over the speed, which I'll call v1. This is the main expression that we need. So we need to find AB, but we already know the definition for speed. The speed in a vacuum is c. That's where this c that we have comes in. I will use a recall. Recall that we saw that n is equal to speed of light in a medium we got the refractive index of a medium in terms of speed of light in a vacuum to the speed of light in a medium. The speed of light in a medium. Now the medium is the block and the speed is v1. So our n will definitely be equal to the speed in a vacuum, which is c over v1. And this implies that our v1, which we chose here, will therefore be c over n. Will be c over n. This implies that my equation, which I've called star, will give us the time now as AB over the speed, which is c over n, which will give us NAB over c, which will give us NAB over c. This can be recorded as another expression. So I want us to look for AB. Look here. The distance AC, we shall say that our AC is T. That is still our thickness. I am going to use a trig function that can help me find AB. Using cos, the cosine of theta in this triangle ABC would be equal to the adjacent, which is T, over the hypotenuse, which is AB, in triangle ABC. This implies that my T, I'm interested in AB. If I make AB the subject, I'll get it as T over the cosine of theta. But for the students attending this lesson, it should be important to note that 1 over cos theta is sec theta or secant of theta. Therefore, it implies that this AB, if we apply for that, is the same as T, the sec of theta. So if I substitute in star, if I substitute in our double star or double equation for our AB now, I would get the time. The time T would indeed be equal to N times AB, which is now T, the sec of theta. Our AB is now T, the sec of theta, divided by C, which gives us the expression that was required by the examiner, which gives us our expression that is required here. So the working should be systematic and consistent. Systematic and consistent. That gives us that simple proof or derivation that our time taken, t must be noted from the start as the time taken for the light to emerge. For the light to reach point B, we say it is ready to emerge. So the time it takes is AB, and we are being able to show that our AB is nt, the sec of theta over c, where c is definitely the velocity of light in a vacuum as specified in the question. The sketch is very important because the examiner needs to see what you are looking for and how you interpret it. And of course, this expression was very, very key. And given that we derived it, and I told you that you can define refractive index in terms of speed of light in a vacuum to speed of light in a given medium, is very, very important for high school students, and of course also ordinary level students. I am assuming that those capturing that are almost done with that, so that we can take a look at our next example, which I'll call question 3. We are basically applying the knowledge of Snell's law, or n sin I is a constant, in almost all the questions we are doing. I will be rubbing off this question to replace it with our next number in Q. The several examples that teachers are supposed to do in your different lessons, in your different schools, are usually supposed to be selectively chosen and are intended to build the confidence of the student and, of course, to make the student familiar with the questions and how they can be interpreted. Question number 3 is dependent on parallel planes. We have different planes here, and we shall consider light incident. Light is incident from a medium at an angle of 40 degrees. It is refracted in another medium, and it is further refracted into another medium. If this medium in the center is a liquid, and we are having light coming from another medium, we can call it X, whose refractive index is 1.54. And then we have another medium, we can call it Y, whose refractive index is 1.44. We are given these angles from the question, that this is 50 degrees. And here, the light grazes along here. So we have this as 90 degrees. The refractive index of the liquid is among the things that we want. So we have the question here. We have light incident from a medium that is called X to another medium which has a liquid of unknown refractive index, and to another medium Y which has refractive index of 1.44. And they are telling us to use the arrangement available to find the refractive index of the liquid and also find the angle of refraction indicated as R. So to find the refractive index of the liquid, since we have the refractive index of X, will require us, first of all, you notice that the angle of incidence in medium X is 40 degrees. In our solution, I can make a brief extract. If I make a brief extract of that, my I is 40 degrees. My R here is going to be, since these are alternate angles, this and this alternate from your angle geometry. So the value of R here is 50 degrees. And since we are interested in NL, this NL is required and our NX is known. So we will perfectly use N sin I. Using our N sin I is a constant. Our NX, the sine of I, which is 40 degrees, should be equal to NL, which we are looking for, the sine of I, which is now 50 degrees. And when we substitute, upon making NL the subject, we shall get NX, the sine of 40 degrees, over the sine of 50 degrees. This will definitely give us our 1.54 sine of 40 degrees over the sine of 50 degrees. If you are using your calculators, the refractive index of the liquid, I will give you an opportunity to compute and try to get the refractive index of the liquid as specified by substituting in those values. When you substitute in to 3 decimal places, those who are finished computing, I expect you to have a value of 1.292 if you recorded to 3 dPs. If you recorded 3 dPs. The second case, they want us to find the value of the angle of refraction. The value of the angle of refraction here. I will use a general expression running from here to there. The fact that we are given this as 90 degrees, my following students, the students following this lesson, I want to emphasize this, that if light is coming in at this face and is refracted at this face with the indication of this, from a fact that we are yet to discuss probably in our next lesson, it implies that this angle here is the critical angle of medium X. This angle becomes the critical angle of medium X. We have already got our NL here as 1.292, and this angle here is 50 degrees. So if they are asking us to find the angle of refraction, which is this one, I am going to take N sin I at this point will be equal to N sin I at that point. And that implies that if I take this medium and that medium, my n liquid, this is that one, the sine of 50 degrees. The refractive index here should be equal to the refractive index, since we want this, the refractive of the liquid should be equal to n, ny, this ny here, the sine of r, and should be equal to, if I reversed light to n, this medium should be considered to be air. That medium is air, which should be right from there, which should be equal to n, the first medium was x, nx, the sine of 40 degrees, which should also be equal to n the n sine I at this point should be equal to n sine I at this point, should be equal to n sine I at that point. So even if we consider only those two, we should be able to find our value. Given that we are interested in R, we shall therefore consider the angle of incidence here, this angle that I call the critical angle, by taking the same condition we took right over here, will also be equal to R. So we shall consider this as the expression we are going to use. We shall consider nx. We can use this, we can use this. But since we have just calculated this, it is important that we use this where the values are known. It is important that we use this where the values are known. We know ny and we know nx. We know ny and nx. Therefore, if we substitute our ny, that means our 1.44, the sine of r which we are looking for should be equal to our 1.54, the sine of 40 degrees. And if we compute by making sine r the subject, we shall get a 1.54, the sine of 40, divided by the sine by 1.44. And when we compute to find the value of r, we shall find the value of r being obtained from the arc sine. This gives us a value of 0.68742. Even if we took it at that point, r would be equal to the arc sine of that value, 0.687425 and this will give us the angle as 43 point approximately 4 degrees. So the value of the angle of refraction at this point will be 43.43 approximately, if we write to 2 decimal places. 43.43. The simple rule of n sine I at each interface is very, very important here. The application of n sine I at each interface is very, very important. As the students are capturing that, I want to continue to encourage you that practice makes perfect. Practice makes perfect. And as a science student, you must have it on your calendar to try out at least 5 numbers, be it mathematics, be it physics, but each day you must do at least a number or 2. In addition to, of course, the other revision exercises you give yourself, especially now that you're at home and you're not directly under the care of the teachers. I want to thank the parents, meanwhile, who have taken up our role effectively. Those parents that have effectively ensured that their children are reading, I want to congratulate you. I know it is not an easy task. Very many parents already say they cannot be teachers, but a privilege that did not come very well has given you an opportunity to test the waters, and I want to thank those that feel they have done their best. To the students out there, I want to encourage you to keep reading. The teachers are strict, and not very many parents will be as strict as the teachers. That is a hard fact that I must be able to air here. And therefore, whereas the parents are trying to assume the charge we normally take while they give you to us, we want to ask you to continue to be those good students that will actually drive yourselves with even minimum effort. At this point, I will capture a few questions right over here and probably challenge you to try them out as our lesson tends to the end. I will capture a few questions right over here, and I will assume that you have understood well enough. This lesson is ideally meant for the S6 students, but senior 5 students that have been following, even senior 4, this particular concept cuts across. I am sure you will thank me later. I want to proceed and utilize the remaining time to put a few questions. But in addition, I want to challenge all the learners out here that the major textbooks for physics are Advanced Level Physics by Neil Conan Parker. We have Understanding. We have Advanced Level Physics by Tom Duncan. And we have Physics by Roger Manchester. Normally, textbooks are known by the titles of the authors. If you just mention an author in any bookshop, they will give you the textbook. Allow me to put these numbers for you to try out. And as I always say, you must be keen for such questions to ensure that the angle the question gives you is the right angle for you to use, because as I earlier told you, this exercise has 2 common angles. There is an angle of incidence and an angle of refraction, and usually we trick students by giving, for example, an angle like this. It is very clear here that the normal is this one, and therefore a student who fails to identify to identify the angle of incidence, will definitely fail to get the correct answer. We have water in the first medium where we have the incident ray, and then we have glass, and we have air. The refractive index of the different media are given, and they are telling you to calculate part 1, the value of R, the angle of refraction, R, and part 2, the angle of emergency. You can call it even E. You are given the refractive indices for the different media. The next question is over there. You are given various refractive indices. And they want you to use, this should be velocity. Of sound. That velocity of sound is in kilometers per second. Yeah. For the last question, which is number 3, I have summarized it. But I want to caution students. When we meet next, I will simply give you the answers that I expect you to have got. I will not rewrite these questions. You will be expected to work through them and compare. The last question, they want you to find the velocity of light in the liquid. They have given you liquid and air, and the speed of air has been given there. I want to definitely thank you and encourage you as usual to continue reading, stay at home. I want to thank the management of BBS TV, the gentlemen men behind scenes, the gentlemen on camera, the gentlemen in the production room, and all my colleagues that are teaching all over. I will continue to applaud you. I want to wish you a nice weekend and remind you that there is a lot of work on my YouTube channel, Teacher Kakuru. Please make use of it. And don't forget the Let's Learn from Home Facebook page as well. God bless you. Gachali Mabaga.
Somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero lya bawala n'abalenzi tusomesa arts ne sciences.